section, we've went through identities, we found the inverses, yep, did all that, found the inverse. All right, so now what we're going to do is figure out how to use inverse matrices to solve systems of linear equations. Now you've already done the hardest part. The hardest part is the actual solving of the inverse matrix. That's the longest and most tedious step. So hardest part's done. Now all we have to do is use that inverse to solve for it. Alright, so using inverse matrices to solve systems of linear equations. If A, so if matrix A is an n by m matrix, with inverse a to the negative 1 power, and X is an n by 1 matrix. So remember, row by column, so it only has one column of variables. And B is an n by 1 matrix. Then we have the following equation. So this looks complicated, not too complicated. So notice this equation is a times x plus b. In real math world, if that was my equation, I wanted to solve for x, I would just divide out the a, right? And you would get x is equal to b over a. But these represent matrices. They're not just numbers. So to do the inverse of matrix multiplication, you take the inverse matrix. So to solve for x here, when we're dealing with matrices, you have to do the inverse of a. If this was just normal solving equation, the inverse of multiplication is division. But these are matrices. So the inverse of matrix multiplication is taking the inverse of the matrices. So what we're going to be doing is we're going to be taking that inverse matrix, which we all know how to find, and we're going to be multiplying by b, where b is going to be the constant matrix from those constants on the right side of the equal sign. Okay? All right, you ready for this? Here's our first problem. 2x minus 3y equals 1. X plus 5y equals 20. We could solve that by graphing. We could graph those, see where they intersect it. We could solve it using substitution. We could solve this for x, plug it in, solve for y, plug back in, get the x. We could do elimination method, multiply this by -2, eliminate the x's, solve for y, plug it back in. We could do row operation, which if we did row operation, remember row operation, we would set it up how? It would be 2, -3, bar 1, right? 1, 5, 20. So that's row operation. So now what we're going to do is we're going to use the inverse and the coefficient matrix to solve it. So to do the inverse, all we're going to do is we're going to set up our augmented matrix. We're going to use 2, -3, 1, and 5, because those are my coefficients of the left side of my variables. I'm going to ignore the 1 and 20 right now, and I'm going to put up my identity matrix so that I can solve for the inverse. Lower left-hand corner. Get it 0. What do I do? I like that. -1/2 R1 plus R2. So R1 stays the same. -1/2 times 2 is -1 plus 1 is 0. -1/2 times -3 is 3/2. 3/2 plus 5. 3/2 plus 10/2. Yep, 13/2. Negative 1/2 times 1 is negative 1/2 plus 0 is negative 1/2. And negative 1/2 times 0 is 0 plus 1 is 1. Okay? All right, let's get rid of this funky fraction. Let's turn that into a 1. Multiply by the reciprocal, 2/13, R2. So 0, 1, that would be, what, negative 1/13. And then 2/13, 2, negative 3, 1, 0. All right, negative 3 to a 0. Sure. 3R2 plus R1. So 2's staying the same. It's not going to change. All right. 3 times 0 is 0, plus 2 is 2. 3 times 1 is 3, plus negative 3 is 0. 3 times negative 1/13 is negative 3/13. Negative 3/13 plus 1 is negative 3/13 plus 13/13. No, not 13/13. I can't see it in my brain. Negative 3/13 plus 1 is negative 3/13 plus 13 over 13. So 10/13. You guys okay over there? 10/13. 3 times 2/13 is 6/13 plus 0 would be 6/13. All right, turn that 2 into a 1. Yep, 1/2 R1. 1/2 R1. So that would be 1, 0. And then it would be 5/13. The reason why I'm getting that is if I take 10 divided by 2, that turns into a 5. 5/13 doesn't reduce. 6 divided by 2 is 3. 3/13, that does not reduce. And then we get 0, 1, negative 1/13, 2/13. So my inverse is 10/13, 6/13, negative 1/13, and 2/13. Yes, thank you. I was looking here, not there. Thanks. So 5 and 3. Okay, so we found the inverse, which is great. So now what I want to do is I want to take my constant coefficient and multiply that by the inverse. So I'm going to take that and multiply it by a 2 by 1 matrix of just the numbers 1 and 20. And now it'll get me my x and my y's. So now let's think about the dimensions. This is a 2 by 2. This is a 2 by 1. So can they multiply? What's the product going to be? A 2 by 1. Good, I'm running out of space. So 2 by 1. So now we got to figure out what those numbers are. This is where your calculator is going to be your friend. So 5/13 times 1 is 5/13. I'm going to put my numbers over here. 5/13 times 1 plus 3/13 times 20. Do it in our heads or do it on a calculator. 5/13 plus 3/13 times 20. I'm getting 5. See if you guys get 5. Yeah. So now let's do the second row, column 1. So negative 1/13 times 1 plus 2/13 times 20 times 2/13 times 20, 3. So our solutions would be 5, 3. Is this easier than row operation? Personally, I don't think so. I think it's a lot of extra work to find the inverse, but there it is. It makes it easier to solve it on your calculator when you're doing your inverse, because your calculator can't do step-by-step augmented matrices. So if you have your calculator, I'll show you how we can do that. So you can check. Check that out. Write this here because I'm going to lose it. I'm going to take it off. So 2, -3, 1, 5. So we're going to have to make 2 different matrices. We're going to have to make a 2 by 2 matrix and then a 2 by 1 matrix. Go into your matrix list. Let's change A into a 2 by 2. And we'll make it our coefficient matrix. Coefficient meaning the coefficients in front of our x and our y variables. 1 and 5. So those were our coefficients in front of our x and y variables in our equation. And then we're going to have to go in and make the constant matrix. So let's go down into matrix B, edit that out, and then turn that into a 2 by 1. And that was what, 120? So, yeah, it's a lot of work to input them, but once you have it, then you can do all sorts of good stuff with it. So to get our answer, we need to take the inverse of A, and we need to multiply it by matrix B, right? So if I select matrix A, and then do the inverse of it, so that x to the -1 power, times matrix B. And then hit enter, 5, 3. Okay. You guys got it? All right, that's all I had for notes. Let's go ahead and practice these. Grab yourself a practice space, whether it's plastic sleeve